Okay, problem 2. There are different ways you could do this problem. We now have systems of equations, so you could do it with systems of equations. Back when we learned this was actually a homework question, and we were making tables to organize our information. So you could have done either way. If you did systems of equations, just make sure you tell me what x and y represent. If you did the table, we had our 2 planes, San Diego and San Francisco. What formula would we put across the top?
Rate times time equals distance.
So 2 planes leave at the same time. One is going to San Diego, the other one to San Francisco. San Diego is 50 miles per hour slower than San Francisco. Do we know how fast San Francisco is going? So that could be x. What would this one then be?
X
Minus 50. In 1/2 hour, so my time is? The planes are 275 miles apart. Think about what's happening. One of them is going north, one's going south. What would you have to do to their distances to get how far apart they are? So we're going to add them up to equal 275. So if we do our formula, rate times time equals distance, so 1/2 times x minus 50. This can just be 1/2 x. So we add those together, and it equals 275. So we get x to equal, if you add over the 25, 300. Then you have to write a sentence. X was the San Francisco. So the San Francisco is 300 miles per hour. San Diego flies. So 300 minus 50 would be 50 miles per hour. Is that one okay? Number 4. All right. So if we distribute 3x squared minus 2x plus 2 equals 0. If you try slip and slide, is there anything that multiplies to 6 and adds to -2? No. So what do we have to do? X equals, so you should know this, opposite of b, plus or minus the square root, b squared minus 4ac, all over 2a. So the opposite of -2 is positive 2, plus or minus the square root, -2 squared minus 4 times 3 times 2 over 2 times 3. So we get 4 minus 24. Okay, how do we break apart the square root of -20? It's a negative, so we have an I, so 2i radical 5 over 6. Anything with i's, you have to write in standard form, a plus bi, so if we separate it, 2 over 6, so 1/3, plus or minus 2i radical 5 over 6, or I radical 5 over 3. that one okay? Number 6. So you probably tried slip and slide. Does anything multiply to 12 and add to -5? No. If you're going to do quadratic formula, you have to back up and do it off this one, not what we tried to slip and slide. So the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So we get 5 plus or minus square root of -23 over 4. So it's a negative, you have to take out an I. Anytime it has an I, you have to write it in standard form, so just break it apart. So 5/4 plus or minus I radical 23 over 4. Is that one okay? Number 7. There are 2 different approaches for how to solve this problem. You can either get a common denominator, or we can multiply to cancel our denominators. So do you want common denominator or get rid of our fraction? Get rid. Okay. We did usually factor everything first. X squared minus 9 factors into x plus 3, x minus 3. And I always told you to make a note what x can't be, just so that at the end you can check yourself. What can x not equal in this problem?
3.
Why?
Because it makes the fraction 0.
Good. So, our strategy is to multiply by what's on the bottom. If you take it to one term, everything gets multiplied. So that cancels these. X minus 3's drop, x plus 3's drop. So what I have left is 12 equals 2 times x plus 3 minus 3 times x minus 3. So if we distribute, Michelle?
So do you multiply each of them by like the same and the opposite?
Well, I just started with this one. Since it had both on the bottom, I had to multiply that fraction by both. And since I did one of them by that, they all did. And that took care of all my denominators. Now, if I still had something left on the bottom, I'd have to take them all times that as well. So you get negative x plus 15. If I subtract my 15, divide by a negative, I get x to equal 3. But what's wrong with that? It can't be 3 because that makes the bottom of my fraction 0. So this one is a no solution. Is everybody okay? Okay, we want want to solve this, how do we get rid of a square root? Square each side. The square root and the square cancel one another, so we have 6 minus 4x equals 49. Subtract over our 6. Divide by -4, so -43 over 4. You should always check on these problems because sometimes we get answers that don't work. So if you plug that back in, you can use your calculator. You don't have to show the work. You get the square root of 6 plus 43, which is 7. So check it. You can use your calculator for that. It does work out. Problem number 9. If you have an absolute value problem, whether it's an equation or an inequality, you have to isolate the absolute value first. So I'm going to start by subtracting over my 3. So the absolute value of 5x minus 6 is equal to 5. Absolute value measures how far you are from 0, so it could be equal to a positive or a negative. So then we rewrite the problem without absolute values. 2 equations. 5x minus 6 equals 5, or 5x minus 6 equals negative 5. Because the absolute value of 5 is 5, the absolute value of negative 5 is 5. If we solve those, we get 11/5 and 1/5. And like any equation, you can always check those by plugging them back into the original. Problem 10. When you have an absolute value, when you have a quadratic inequality, start out treating it like a quadratic equation. So we would get 0 on one side. We would factor what multiplies to 4 and adds to negative 5.
-1 and -4.
Okay. If it were equal to 0, you would just tell me x is 1 and 4. Think about that for a moment. We've talked about different methods for doing this. If you think about what your quadratic looks like, you may get it from there. When we were solving these, because we had both equations, or quadratic equations and rational ones, we usually made a sine line. So those are the places that it would hit the x-axis. We need to figure out when it is greater than 0, so when it's positive. So we pick test points. Smaller than 1, in between 1 and 4, bigger than 4. And we plug them in. You can put it in right here. 0 minus 1 is negative. 0 minus 4 is negative. If you multiply two negative numbers, you get a, if I put in 2, 2 minus 1 is positive, 2 minus 4 is negative. A positive times a negative. If I put in a 5, 5 minus 1 is positive, 5 minus 4 is positive, 2 positives give. All right, we wanted greater than 0, so we want the positives. So we want these sections. It wasn't equal to, so all parentheses. So it'd be negative infinity to 1. Union 4 to infinity. So anytime your problem has an inequality, you should have an interval at the end. Okay, number 12. All right. So we have to isolate the x of value. It is by itself. So again, there's probably 3 different ways that we might do this problem. And I don't care which of those ways you pick. But what we talked about, what worked for most of you in class, we said great or. That's an or statement. So for an or, we did 2 separate inequalities. The first one, nothing changed. The second one, we flipped the inequality and made it a negative. Is everyone with me right here? There are other ways you could do like one big compound inequality. You could even do this with a sign line, but this is probably the easiest option. So if I add my 1, divide by 2 on both. Okay, I didn't require a graph, but if you think about it, greater than or equal to 2 is 2 and everything larger. Less than or equal to negative 1. How would I write that in interval notation? It has brackets because of the equal to. We talked about when we did these, a great or is an or. You always get 2 separate pieces when you solve those. When you have less than, that was an and your solution was just in between 2 numbers. Problem 13. This is another inequality. This is a rational one. So we did it a lot like the quadratic. We had to get a single fraction on one side, 0 on the other. And we already have the correct setup for that. So we want to be able to do the sign line. We have to figure out what makes top and bottom 0. So if you set the top equal to 0, we get 4/3. We set the bottom equal to 0, we get -5. So those are the 2 points we put on our sign line. Then we pick test points, smaller than -5, in between the 2, and bigger than 4/3. I am plugging these back into this fraction. So if I put in a 6, I get a negative on the top, a negative on the bottom. Negative divided by a negative is positive. If I put in a 0, we get a negative over a positive, which is negative. If I put in a 2, positive over a positive is positives. Equal to means bracket, but what can x not be? Right, we can't have a 0 on the bottom, so the -5 has to get a parenthesis. We said less than 0, so less than is the negatives. So it's this section, parenthesis on the -5 because it's from the bottom, but the top could be 0. So it's parenthesis -5 to 4/3. Are we okay with that?
Wait, how did you say about the bracket?
Because it had an equal to 0. So equal to would normally mean brackets on both, but because we have a fraction, the bottom gets a parenthesis no matter what. So f composed with g means f of g of x. So you start on the inside. G is -3x plus 4. We are plugging that into f. It's taking the place of the x in that equation. So we have 2 times negative 3x plus 4 squared minus 1. How do you square that parenthesis? Well, so we get 9x squared minus 24x plus 16. Distribute your 2, so 18x squared minus 48x plus 32, and then we have that minus 1 on the end. So final answer, 18x squared minus 48x plus 31. Problem 19. I'm asking you to graph this, and in the directions it said to give the parent function. What's the parent function? Okay, so you can do just a t-chart, you can write it down or do it in your head. The square root of 0 is 0, square root of 1 is 1. What else can we do the square root of? Square root of 4 is 2. Can we do negatives? No. So remember our parent function, we did a dashed line, it just looks like this. The transformation, what does a minus 3 do? So I moved each of these points to the right 3. And that's our final answer. (22). All right, stretching and shrinking is harder. So one trick that we talked about with these is kind of like writing out your points. My parent function is x cubed. 0 cubed is 0. 1 cubed, 2 cubed. Okay. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8. So more points than you have to have, but I just want to make sure you see the graph. So it's our chair. If you can't remember what the transformation is, here's what I want you to look at. The negative 2 is on the outside. I always said outside changes y, and it does what it says. So it's going to take these y's times negative 2. 0 times negative 2 is still 0. 1 times negative 2 is negative 2. 8 times negative 2 is negative 16. I'm not going to graph that one. Negative 1 times negative 2 is 2. Negative 8 times negative 2 is 16. So what it did is it flipped my chair, reflected it over the x-axis, and stretched. It's getting taller and skinnier. So if you're struggling, write out more ordered pairs.